Problem 15.164 involves this bucket and lift mechanism. The bucket is being retracted in this direction, and it's also being, this arm right here is being lowered. So we have a velocity of the bucket with respect to the frame. There's going to be minus 0.2 meters per second. Cos theta I plus sine theta j is the unit vector points in that direction, and of course the velocity is negative in that direction. And then the angular velocity is given to us as a negative 0.08 radians per second to k. The length of this, I'm going to call this 6 meters here, L, and the angle theta right here is 30 degrees. So we're defining the velocity of B and the acceleration of B. Velocity of B is equal to the velocity of B prime, which is that footprint velocity, plus the velocity of B with respect to the frame. The footprint velocity, my xy axis is going to be this way. Little x is this way, little y is that way. The capital X and capital Y are lined up exactly with that. And the little xy is going to be rotating. So if you mark the point in where B is located right here in the little xyz frame, and then watch that rotate with the frame and measure that velocity with respect to the capital XYZ frame, then that is omega crossed into L cosine theta I plus sine theta j. And then the velocity of B with respect to the frame, as if this rotation right here of this arm wasn't taking place, what do we have for the velocity of B? And we have this velocity right here. So that's repeated right there. And you gather your terms together and you get the I component being 0.0668 meters per second, and the J component being a negative 0.516 meters per second there. So that you get overall magnitude of 0.52 meters per second at 82.6 degrees below the positive x-axis. The acceleration of B is written as the acceleration of B prime plus the acceleration of B with respect to the frame plus the Coriolis term. Again, this acceleration of B prime is just the acceleration of that point that remains fixed in the rotating reference frame, and we measure the velocity of that point with respect to a fixed reference frame. Well, that's going to be an alpha crossed r plus omega crossed r. Well, the alpha for this rotation is 0, so that term goes away, and the omega crossed r becomes just minus omega squared r, and my r is L cosine theta I plus sine theta j. The acceleration of B with respect to the frame, we're told that this is a constant acceleration in that frame of reference, so the acceleration then is going to be 0, and then the Coriolis term is 2 omega k crossed into v sub b slash f, and the omega is given right here, the v sub b slash f is given right there, so and there it's repeated. So when you gather your terms together here, you'll get a negative I coefficient of minus 0.0493 meters per second squared, and a positive J of 0.00851 meters per second squared. And when you find the magnitude, that comes out to be 0.05 meters per second squared at 9.81 degrees above the negative x-axis.